Let's talk about the direction of thermodynamic processes. থার্মোডায়নামিক বা তাপগতিবিদ্যার যে সমস্ত প্রক্রিয়াগুলো আছে সেগুলোর সঙ্গে যে দিক বা ডিরেকশন ইনভলভ সেগুলো নিয়ে এবার আমরা একটু ডিসকাস করব. If we look into figure 1, we can see that there is a metal box kept at temperature 70 degrees Celsius. And inside the metal box, we have put an ice cube. Temperature of this ice cube is 0 degrees Celsius. Now, spontaneously, what will happen? Heat will be flowing from the metal box, as it is at a higher temperature, to the ice block. And the temperature of the ice block will be increased and it will melt. As a result, the temperature of the metal box will go down, but the reverse thing will never happen. So this is a one-way traffic. The process occurs only in this direction. This direction is not achievable. This kind of processes are called irreversible process, একমুখী বিক্রিয়া বা একমুখী প্রক্রিয়া. Now all the process which occurs in nature are the irreversible one, and this types of processes will proceed spontaneously in one direction but not in the opposite direction. For example, heat flows spontaneously from a hotter body to a cooler body, such as a free expansion of a gas, such as if we slide a piece of book on the table, then as a result of friction, heat is generated. But this is a irreversible process. No one has ever observed the reverse one. That is, if the book is initially kept at rest on the table and that would spontaneously start moving on the table, and the book and the table would cool down. This will never happen. Now, shortly we'll be discussing second law of thermodynamics, which will determine the direction for such processes. Now, let me show you another picture which tells us that we have a same ice cube at 0 degrees Celsius, but now the metal box is kept at 0 degrees Celsius too. And if the temperature of the box is increased with a very small amount, that is an infinitesimal change of the temperature of the box is made, then this ice could melt into water. And of course, if an infinitesimal decrease in the temperature of the water can be achieved, then this water will again freeze. So this is a reversible process. This process occurs in both directions, in this direction and this direction. Now, beside all the irreversible processes occurring in nature, we can think of some process which are a reversible one. And a system that undergoes such an idealized reversible process is always very close to the thermodynamic equilibrium within itself and with its surrounding. মানে যে সিস্টেমটা, যে সংস্থাটা রিভার্সিবল প্রসেসের মধ্যে দিয়ে যাবে সেটি তাপীয় সাম্যের খুব কাছাকাছি থাকে নিজের সাথে, নিজের যে পার্টগুলো আছে তার মধ্যে, এবং উইথ দ্য এনভায়রনমেন্ট মানে উইথ দ্য সারাউন্ডিং, তার আশপাশের সাথেও থার্মোডায়নামিক ইকুইলিব্রিয়ামে থাকে. And any change of state that take place can then be reversed by making only an infinitesimal change in the conditions of the system. For example, we can reverse heat flow between two bodies whose temperature differ only by an infinitesimal amount. So only a very small change of temperature of one or the other will be sufficient. Now, reversible processes are thus, we can call it, thus they are the equilibrium process. Now, of course, if a system is in equilibrium, thermodynamic equilibrium, so there will be a uniform temperature throughout the system. So no heat exchange will take place. So a reversible process, is an idealization that can never be precisely attained in our real world. But with a very small temperature gradient and a very small pressure differences, we can keep the system very close to the equilibrium, and we can make the process nearly reversible. But so this is an ideal situation. But in contrast to reversible process, if heat flows with a finite temperature difference between two substances, free expansion of a gas, conversion of work to heat by friction, this all are irreversible processes, and no small change in conditions could make any of them go in the other way, that is, go in the opposite direction. মানে এই সমস্ত প্রসেসগুলোতে কন্ডিশনের কোনো রকম চেঞ্জই প্রসেসগুলোকে বিপরীতমুখী করবে না. So they are all non-equilibrium process, in that the system is not in thermodynamic equilibrium at any point of the process till the end of the process. Now let's come to disorder and thermodynamic processes. There is a relationship between the direction of the process and the disorder or the randomness of the resulting state. For example, if we have 10 cards and 1 to 10 are written on these cards in order, and if we jumble up and throw it on the sky, it will split up, and those cards will be spread onto the floor. কার্ডগুলো যদি আমি উপর দিকে ছুঁড়ে দিই তাহলে মেঝেতে পড়ার পরে they will be in a spread, they will spread, তারা ছড়িয়ে যাবে. Then there will be no order between them. Similarly, in the free expansion of the gas, the air is more disordered after it has expanded into the entire box. Another example is our clothes, that is, those are scattered all over the floor. All these are examples of disorder. Similarly, macroscopic kinetic energy is associated with organized coordinated motions of many molecules, but heat transfer involves changes in energy of random disordered molecular motion. Therefore, the conversion of the mechanical energy into heat energy involves an increase of randomness or disorder into the system.